Okay, let's try a different one-tailed hypothesis problem. In this case, we're going to look for an increase, and let me go ahead and read the substance of it. The mean number of hours sleeping is 7 with a standard deviation of 2.4. A large sample of 144 meditators shows a mean number of hours sleeping of 7.4, so a slight increase. We hypothesize that meditating, which that should say, increases sleep hours. What are the null and alternate hypotheses for a one-tailed test alpha of O5? Now, right away, you can see the word increases here. Increases suggest it's a one-tailed. It's directional. It's committing to a direction. It's committing to a particular type of effect. Therefore, I'm going to express the alternate hypothesis. The alternative hypothesis is greater than the default of 7. Greater than. Can I then go quite easily and express the opposite of that in terms of the null hypothesis? Sure, it's just less than or equal to. Let's go somewhere else. Can I know which side the critical value will be? Yes, it'll be on the right side. My arrow is pointing to the right, no question about it. What is the particular value of that critical value? Can I convert 05 to a 4-digit number? Yes, it's 0500, 0500. Is there a number that meets that criterion of putting 0500 in the tail? Yes. Now, we're going to choose 1.65. Although, if you can look at the Z tables, you'll realize it could have just as easily been 1.64. 1.65 places 0495 in the tail, 1.64, 0505. Quite annoyingly, they're equidistant. It's another tie. It's amazing what an unfortunate coincidence that is. But we're just going to land on 1.65 because your text does. Traditionally, I've used 1.64. Doesn't matter. I would never get critical about that. Wouldn't take off of that. So in this case, no question. And by the way, we're presuming that 5% lays out here past this goalpost, if you will, and it's definitely on the right side, as we said before. Let's do the math. I've got a huge sample size of 144 with a mean of 7.4. So I've taken my smallest standard deviation and dividing by the square root of 144, which is huge. 2.4 over 12, and I get 0.20. Now, the researcher likes this. To constrain that error term makes it more likely that you'll have a large Z term. If I have a small number down here, it makes my Z bigger. And sure enough, this token improvement of 0.4 of an hour, which is 24 minutes, has yielded a Z score of 2. Now, what happened? Well, this does a pretty good job. We accept or reject the null hypothesis, one-tailed alpha of 05. We're going to reject that null hypothesis. It was a fairly cut and dried proposition. My critical value right here, the goalpost, was 1.65. The Z obtained was 2. It's past that region of rejection, and therefore I'm going to reject the null hypothesis, and we will enjoy statistical significance in that case. This is another example where 144, a large sample size, really helped. But I really want to emphasize that we know that this is a one-tailed test that's on the right. I can tell with the word increased. I want to suggest that here with the arrow. Easily go the opposite way with the null hypothesis. And using that 05, looking in the tables, I know that it's 1.65 positive that goes over here. The math is fairly direct. That's not a big deal at all. We're used to that from chapter 7. My Z obtained is 2, and sure enough, it falls outside that region of rejection, and therefore we reject the null hypothesis.